Right, now we're going to do a Wilcoxon question there, question 4 from autumn 2019. 18 samples there are analysed for their sodium content and their results are expressed in parts per million. At a significance level of 5%, use the Wilcoxon signed rank test to test the null hypothesis that the average value for the method of analysis used is. So we're testing to see if the average value is 160 parts per million. So the first thing we're going to do is we're going to subtract 160 from each of the 18 values. Okay, so 160, say we take the first value there, 174. Well, what I'm going to do is I'm going to store 160 into the calculator, right? So I'm going to store that into variable A, okay, to make life easy and kind of get more mechanical about it. So 174 subtract shift recall A equals 14. So that's our first difference, is 14. 159 then. Next up will be 159 minus shift recall A, and that gives us -1 for this difference, and so forth. The next difference then is I'm working across the way, 178 minus shift recall A, and I get 18. Now I'm just going to pause the video and put in the answers. So this is my table of I've taken 160 from each of these values, so now I have my differences, right? So the column title here is differences. And next up we're going to get absolute differences. And that just means that we're going to ignore negative signs down along. So we're going to have 14, 1, 18, 2, 7, 7, 17, 5, 3, 10, 21, 0, 2, 19, 0, 7, etc. No, I should have them lined up a bit better. -6 and -3. Oh no, they're not going to be minus, of course, because they're absolute. That's our absolute differences. Now we're going to discard. You see this, where we have a difference of 0? We're throwing this away. We're pretending this isn't even in the question. Right? We're going to discard this here because the difference is 0. So we started off with 18 observations, but now n is going to be 16 because we're ignoring items where the difference is 0. Our next job then will be to order these differences. So we can begin with a little chart like this. Differences, right, with the bar here, this means absolute differences, and then I'm going to have a row down below here that'll give that we'll write in the sign of each of these differences, and then down again another row for rank. Now we're going to have 18 or 16 numbers across here. So our first job is to pick out the lowest number from the absolute differences, and the lowest number there is 1. And we'll worry about the sign and rank later. The next lowest number is 2, and there's a 2 2's, so we write in 2 2's. And this is very difficult now. I have it already written down here in front of me, and that's why I shouldn't make a mistake. I'm saying there's supposed to be 2 3's here, 1 and 1 at the bottom. So we have 3 and 3. So you have to be careful at this stage. The 5 is next biggest. There's 1 5, then there's 1 6, there's 3 7's, 1, 2 and 3, and the next biggest number turns out to be a 10, and then we have a 14 and a 17 and 18 and 19 and a 21. We should have 16 values now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And now I'm going to assign each of them from their original sign. Right, we had 1, 1 there, and that was originally negative. We had a pair of 2's, that 2 there was positive, and that 2 there was also positive. So the positive for both of those. The 3 there, we had that 3 was positive, you see. The other 3 was negative, so we'll have 1 positive and 1 negative. Doesn't matter about the order there, I think. 5 then. Where's 5 on the list there? 5 was originally minus 5, so that gets a sign of minus. 6. Where are you, 6? Yeah, 6 was originally negative, you see that? So we have a negative 6. And the 7s then were 2 positives and a negative. Our 10 was originally negative. 14 was positive. Was it? Let's check that. 14 was positive. Yep. 17 and 18 were positive. You can stop the video anytime now and do this yourself to go ahead and check. 21 was positive. And then now we're going to assign ranks. So 1 is on its own as the lowest, so that gets a rank of 1. Now the next 2 are the same, so 2 and 2, they have the rank of 2 and 3, but because they're the same, we add the 2 and 3. So we're going to have the rank of 2 plus the rank of 3 divided by 2, and that gives us 2.5. So each of those guys there gets a rank of 2.5. And then, so we've 1, 2 and 3 used up, and the next rank is 4 and 5 to be spread between the 3's. So they're going to end up with 4.5 each, because we're adding the 4 and the 5 and dividing by 2. So that's 1, 2, 3, 4, 5. 5 there gets a rank of 6. And 6 gets a rank of 7. And then the next 3 ranks is 8, 9 and 10. The average is going to be 9. Right, we added the 8, 9 and 10 and divided by 3. I'm rushing a little bit as I have a 15-minute limit on this. So 10 then gets a rank, because we had 8, 9 and 10, so this gets a rank of 11. 14 gets 12. 13, 14, 15 and 16. So that's all our ranks done. And our next job then, well, of course, I should have at the start assigned a null hypothesis. Now, you can just go like this. The median equals 0, right? M for median. This is the median of the differences. So, if there's going to be no differences, if the median is 0, it indicates that, what does it indicate? That there was no variation away from the 160. And HA, the alternative hypothesis, this can be less than, greater than, or not equal to, and we have to look at the wording in the question. In this case, you see, that we're testing that the average value for the method of analysis used is 160, and the opposite of that is not 160. So they're not saying less than or greater than, you know, so it's going to be not equal to 0. So the median difference is not equal to 0 as our alternative hypothesis. And we're testing at alpha equals 5%. Now, because it's a not equals to sign here, this indicates a two-sided test, so it'll be alpha sub 2 when we go to look up our tables later to get our critical value. Should have maybe done this at the start. Now, moving on, we're going to get our W negative. This is a stat. We're going to add up the negative ranks. So let's identify the negative ranks. You can see them there. There's the ranks with a negative sign. We have 1. We have the 3, the 5 and the 6. Well, they're not the ranks, they're the differences. That's 4.5. That's going to be, sorry, something happened there. 4.5, the 6 and the 7. Rank 9 there and rank 11. and rank 15. They're the negative ranks. So we'll add them together, those numbers in the circles. If you add them together, you'll end up with 53.5. And then we can get the positive rank stat. That's adding up the other ranks that aren't circled. You'll end up with 82.5. Right? And we'll be choosing the lower of those two ranks. The lower of those two values will be what's known as our test stat. So we can call that W stat. Is the lower of those two. W stat is going to be 53.5. And we're going to be comparing that with W crit, which we'll get from the tables. So let's see if I have a table handy here. W crit, we'll be looking up the table. Remember, n equals 16. So here's the table. Remember, n equals 16, so that'll be our row here, and then we have to decide alpha 5%. Well, remember, we're alpha 2, so it's this one here, 5%. We're two-sided down along here, and we get a critical value of 29. Okay, so I'll just get rid of that. 29 is our critical value. Now we have a critical value and we're going to compare it to W stat. Now, because W stat is not less than, so this is our less than sign, and I'm putting a line through it. W stat is not less than W crit. Because W stat is not less than W crit, we fail to reject the null hypothesis. So the evidence suggests that there is no difference. The evidence suggests that there is no difference. So the evidence suggests that the average is 160 parts per million. Right, that's 12.5 minutes done. So I have 2.5 minutes left on this thing. We can check as well. This is something that's optional. You can check by using this formula. N by n plus 1 over 2. Does that equal the sum of our W's there, W minus and W plus? Now n is 16. So you're going to have 16 times 17 over 2. Does that equal the sum of our W's, 53.5 plus 82.5? And when we add those together, we get 136. And when you do out this guy on the left, you get 136 as well. So that indicates that we've done things correctly. So we're failing to reject HO. And that's the procedure there.